So chapter 2G looks at the normal distribution and the 68, 95, 99.7% rule. Now, a normal distribution is a symmetric bell curve. So if we had a histogram that was at least roughly symmetric, and you can see that it does roughly follow this kind of bell curve shape that I've just drawn in red. Now, these sort of normal distributions show up all the time in real life. You can see in your textbooks, we've got 4 examples of histograms that follow these approximate bell curve shapes. So if you ever have a histogram that follows a normal distribution, or at least a approximately normal distribution, then you can use the 68, 95, and 99.7% rule to solve problems regarding them. So let's have a look at what these are. To start off with, let's have a look at the mean value and what we can take from that. So we got 50% of data lies on either side of the mean. So what this looks like, let's draw a bell curve, and let's say this is our mean value. We've got 50% of our data on either side. Now this is where the 68 part of the rule comes in. We've got 68% of the data lies within 1 SD, SD standing for standard deviation of the mean. Now let's draw this graphically so you can see it. We've got our bell curve. Let's say this is our mean. I'm going to put a mark here and a mark here. This point is the mean plus 1 standard deviation. And this point here is the mean minus 1 standard deviation. So inside here is 68% of the data. Now, obviously, all the data is 100%. So the 2 areas out here will be 32%. So these 2 areas add up to 32%. Now, because this is symmetrical, this needs to be the same as this. So all the data that lies on this side will be half of 32, and all the data that lies on this side will be half of 32. And half of 32 is 16. So we can conclude that 16% of the data lies above this mean plus 1 standard deviation, and 16% of the data lies below the mean minus a standard deviation. So now we've got this diagram here where we've got our bell curve. This point is the mean minus 2 standard deviations, and this point is the mean plus 2 standard deviations. If we have 95% of our data lying between these 2 points, we've only got 5% left to share between this little area here and this little area there. Half of 5 is 2.5. So in here, we've got 2.5%. And in there, we've got 2.5%. So I can say that 2.5% of the data lies below the mean minus 2 standard deviations, and 2.5% of the data lies above the mean plus 2 standard deviations. Finally, we get to the 99.7. Now, because we've gone from 1 standard deviation to 2, I'm sure you can guess that the next one will be 3 standard deviations. So we've got 99.7% of data lies within 3 standard deviations of the mean. Now this point's going to be way over, almost at the very end. We've got 99.7% lying in here. Let's work this one out as well. So what's left over is 0.3%. Now half of that needs to go on either side. So half of 0.3% is 0.15. So here we've got 0.15% lying above the mean plus 3 standard deviations. And we've got 0.15% below the mean minus 3 standard deviations. So we've got an example here. We've got pizza delivery times are at an average of 25 minutes with a standard deviation of 5 minutes. Part A asks, what percentage of pizzas are delivered in under 30 minutes? To answer this, I'm going to draw a diagram which is going to help us answer both of these questions. So right in the middle, we've got our mean or average, which is 25. Now I'm just going to notch off each standard deviation point. So that is our mean, that is plus 1 standard deviation, plus 2, plus 3, minus 1 standard deviation, minus 2, minus 3. So part A asks, what percentage of pizzas are delivered in under 30 minutes? Well, we can see that 30 minutes is 1 standard deviation above the mean. So we should know that on this side should be 16% of deliveries. So everything on the other side here needs to be 100% minus that 16%. That equals 84. So in here is 84% of deliveries. Therefore, 80% of deliveries are delivered in under 30 minutes. Now let's look at part B. we've got 2,000 pizzas that are sold in a week. How many were delivered in under 10 minutes? We can see here that 10 is our mean minus 3 standard deviations. So we should know that in here, it's just 0.15%. So straight off the bat, we know that 0.15% of deliveries are made in under 10 minutes. We've got 2,000 pizzas in total. So what we need to work out is what is 0.15% of 2,000. So how do we work this out? Well, what I like to do is, if I write this out in words, we've got 0.15% of 2,000. Now, you can think of per as divide and cent as 100, because it's 0.15%. So when you type this in your calculator, you've got 0.15 over 100 multiplied by 2,000. And this looks a little bit better if you write it like this. If you chuck that in your calculator, you will get an answer of 3. So in total, 3 pizzas were delivered in under 10 minutes. So we got an example from the 2016 VCA Exam 1. We've got the weights of basketball players is approximately normally distributed with a mean of 78.6 kilograms and a standard deviation of 9.3 kilograms. So in total, there are 450 players. The question asks, what is the expected number of players with weights above 60 kilograms? So let's see how far 60 kilograms is from the mean. So we've got 78.6. Let's minus 1 standard deviation, so minus 9.3. All right, so 69.3. Let's minus 1 more standard deviation, and we get 260. So we can say that 60 is 2 standard deviations under the mean. Now, if we look at our graph, if our mean is at 78.6 and here is 60, we know 60 is 2 standard deviations away from the mean. So here should be 2.5% of the data, meaning this part should be 100 minus 2.5, which is 97.5% of the data. So 97.5% of players have weights above 60 kilograms. So all we need to do is find out what is 97.5% of the total players, 456. We can type in 97.5 over 100 times 456. 97.5 over 100 times 456, we get 444.6 players. Now that number is closest to 445. So our answer is E.